Okay, the last congruency theorem we're going to look at is hypotenuse leg. And the key thing here is that you have to have two right triangles. If you have two right triangles and the hypotenuse and one leg of one of the triangles is congruent to the hypotenuse and the corresponding leg of the other triangle, then you have congruent triangles by hypotenuse leg. So let's look at how I've marked this diagram. I know I have right angles. B and G are right angles because I have these little boxes. Therefore, triangles ABC and EGF are right triangles, which is what I need to show somewhere in my proof to use hypotenuse leg. I've marked AC congruent to EF. That is the hypotenuse. The hypotenuse is always across from the right angle. And AB is congruent to EG, though that is one of the legs. Now, it doesn't matter which set of legs you use as long as they are corresponding. Because I have a right triangle where the hypotenuse and leg of one triangle is congruent to the other, I have congruent triangles by hypotenuse leg. Okay? So let's look at example 1. We are given a lot of information. Key here is the perpendicular. Okay? AB is perpendicular to DC. AD is congruent to AC. So I'm going to go ahead and mark the congruent sides. Okay? Now notice there's no box in here because we haven't established their right angles yet. But because AB is perpendicular to DC, we now know that angle ABD and angle ABC are right angles. Definition of perpendicular. Okay? And now we can establish that triangle DAB and triangle CAB are right triangles because we're going to use the definition of right triangles. Okay? So now that we have right triangles, we can work towards hypotenuse leg. We're already given that the hypotenuse is congruent, and notice again, we have a shared side. AB is congruent to AB by reflexive property, and AB is the leg of triangle DAB and a leg of triangle CAB. So now we have hypotenuse leg, hypotenuse leg. The triangles are congruent by hypotenuse leg. All right. So we're going to take this example from scratch. Okay? Let's start with what we are given. This is as given as marked. We have AD congruent to CB, and notice angle D and angle B are right angles, or you could say that AD is perpendicular to DC. So this is going to be one of the most confusing things with proofs, is that there's more than one way to look at this. I'm going to look at it as angle D and angle B are right angles. Okay? So AD is congruent to CB, and angle D and angle B are right angles. And that's given. Okay? Since we know that angle D and angle B are right angles, we can go ahead and make the statement that triangle ABC and triangle CDA are right triangles. Why? Definition of right triangles. Right triangles have a right angle. Okay? So now we've established our right triangles. Notice that we have a shared side. So we can say that AC is congruent to AC. That's the reflexive property. Therefore, triangle ABC is congruent to triangle CDA by hypotenuse leg. Okay? Now, there's another way we could have proven this. We could have started with our given AD congruent to CB, and instead of stating that D and B were right angles, we could have said AD is perpendicular to DC and CB is perpendicular to BA. That is another option. AD perpendicular to DC and CB perpendicular to AD. This is our given. This would only add one more step to our proof. Because we're talking about perpendicular lines, then we would talk about right angles. Angle D and angle B are right angles. Why? Because definition of perpendicular. Then, since they are right angles, triangle ABC and triangle CDA are right triangles. Definition of right triangles. We still have our shared side, AC congruent to AC. Reflexive property. Therefore, triangle ABC is congruent to triangle CDA hypotenuse leg. So there's two options for this proof. Again, because we are working off the diagram, since these angles are marked with a little box, one of two things. They're right angles or they're perpendicular lines.